Well, hey everyone, welcome back. Today we are continuing our conversation around perimeter and area. In fact, today we are going to look at both of them at the same time. So again, trying to decipher the difference between one or the other so that we remember what to do when we do it and how it works. So remember, both of these are just terms of measurement, right? We are really just measuring either distances between coordinates or corners or points on a given polygon, as well as we are measuring like this, the amount of space that it takes up, the area that it takes up. So a couple of things to remember, right? Perimeter, we often talk about it being the outside. And with that, we often use addition. That's kind of the way that we think about it. We have polygon, we have 3, 3, 2, and 2, and we are adding together the distances or the measurement along between these points. And then when we get to area, we are thinking about the inside, and we do that through the use of multiplication, because what we do know is that if this is 3 units and 2 units, we're literally just counting 1, 2, 3, 4, 5, 6, the amount of units on the inside. But we can do that skip counting, right, through multiplication. So again, I know I have 2 groups of 3. So for area, we have what we call a formula, which is just length times width. So the length of your shape times the width of your shape, which is also the exact same thing as multiplying a row times a column, because, well, this is an array, and arrays are multiplication. So that's where we kind of go with all of this. So just remembering these and practicing them is kind of the goal for everything here. And the most common way that we see this is, we will get a polygon, in this case, a quadrilateral, in this case, maybe a rectangle. And, it's going to have its measurements. So maybe we'll call this 6 centimeters and this is 3 centimeters, right? And then it's just going to say, okay, well, given this shape, can you find the area? And can you find the perimeter? So find both of them. So there's a couple of things to keep in mind. Starters, often when they do this, what they're not going to do is label all 4 sides. It's that tricky piece for us to remember and say, okay, well, let's start with the perimeter first. I know that I'm measuring the distance from this point to this point, and that's 6 centimeters. And I'm going to add it to the distance from this point to this point, which is 3 centimeters. And often we will stop there. But the reality is we haven't measured everything, have we? Right? So we always kind of want to make sure everything gets labeled first. So I do know that this is also 6 centimeters because opposite sides of a quadrilateral are equal in measurement here when you have a rectangle, let's say. So there's another 6 centimeters there. And then we need to think about measuring from here to here, which is going to get us another 3 centimeters. So then again, if you've watched these videos, one thing I like to do is just do kind of like a doubles, right? So that 6 plus 3 is 9, which means this is a 9. And then 9 plus 9 is 18. So my perimeter is going to be equal to 18 centimeters. Now, if we think about the area, then there are a couple of things. I could model it so I could count, right? I know that I have, according to this, I have 6 columns. So I'd start with 3 and then cut those in half, and that gives me 6. And then I know I have 3 rows. And again, I can just count all those units, that how many 1 centimeter units are inside this whole shape. How much space does it take up? So again, I know that if this is a row of 6, I could skip count by 6s. So that's 6, 12, 18. And this is pretty cool because area is equal to 18 centimeters squared. Remember that, right? That's just that thing we're memorizing right now. We talked a little bit in the last video about why we do that. And in this case, actually my area and my perimeter are exactly the same, and that's not always going to be. So that's kind of cool that that happened on that first example, because that's another kind of question that sometimes you have to create your own shape in which the area and the perimeter are exactly the same. And that's going to be another video down the road, but hey, at least we can start thinking about it. So let's go ahead and try another one and kind of dive in. Now that we're at the stage of bigger numbers, we do have to be aware of the fact that like often we might get a mixed number in our work to be thinking about. So let's do that. I don't know, let's call these inches, my unit of measurements. So again, here we go. What is our perimeter? How are we going to solve that? Well, the first thing I'm going to do is make sure I label all my sides. So this is also 3 inches because it is the opposite side, right, of a rectangle. And then this is 3 3/4 because this is the opposite side as well of the rectangle. So now that I have them all, again, I'm just thinking about, I'm adding the measurement of each side. So that means I have 3 plus 3 3/4 plus 3 plus 3 3/4. So again, this is actually helpful here because we know if we're adding fractions, the first thing we want to do is make sure that our denominators are the same, which they are. And I have whole numbers here, and I could make these fractions, but actually what I'm going to do, I'm just going to lump these two because 3 wholes plus 3 wholes is 6 wholes. And then I have 3/4 left over. And again, that means I know that this is 6 3/4. Then I can do the same thing. I'm going to say 6 wholes plus 6 wholes is 12. And I'm going to add that to 3/4 plus 3/4. Well, let's see. 3/4 plus 3/4 is 6/4, right? Denominator is the same, so slide it over. Add your numerator. So I have 12 6/4, but that's still not my final answer because the problem here, well, it's not a problem, it's just something to recognize, is that this is top heavy. So of course now we got to take that and convert that into a mixed number. So 6/4 is the same thing as 1 2/4. Again, if you're not sure about this conversion, please go watch the videos on how to convert mixed numbers to top heavy fractions and top heavy fractions to mixed numbers. So this is 1 2/4. So then I'm going to add that to the 12, right? So it's actually 12 plus 1 2/4. And that's going to give me 13 2/4. Wow. So cool. A lot of work. That's okay. Nothing wrong with that. So I'm going to come up here and write that down. So the perimeter is 13 2/4 inches. I am going to have to do a little bit of erasing now, so I have space to work on the area. So if this is something you're looking at, I'd say pause the video and write these things down and think about them. But now I'm erasing. So the next thing we need to do is think about finding the area, right? This 2 things per area and perimeter, finding them both and remembering what to do with what. And remember, area, array, multiply. And it's true because we are just multiplying when we have our area. Let's use a different color here. When we have our area, we are just multiplying areas equal to the rows times the columns, or the area is equal to the length of your shape times the width of your shape. Those things are the same, right? My columns here is a width, and my rows here is a length. And it's also interchangeable, right? Remember that in multiplication, right? 2 times 3 is 6. 3 times 2 is 6. So it actually doesn't even matter which one you call the length or the width. You just need to make sure you're using both those numbers to multiply. And you want to use those adjacent ones, right? You don't want to use those numbers that are directly across from each other. You want the rows and the columns. So what that means is if I'm going to find this area, we're doing 3 times 3 3/4. Okay. So the first rule, and again, we're multiplying fractions. So please watch that video if this doesn't make sense, right? I'm going to assume these are skills we're still carrying. So the first thing I'm going to do is make sure they're both fractions, which neither of them are. So if I put this over 1, it makes it a fraction. So my area is going to be equal to 3/1. This also is not a fraction, it's a mixed number. So I'm going to convert it into a top-heavy fraction. So 4 pieces per 3 holes. So 4 times 3 is 12, plus the 3 more parts that I have. So that's 15 fourths. That's the same thing as 3 3/4. Now that they're both fractions, I just multiply across the top and I multiply across the bottom. So 3 times 15 is 45, and 1 times 4 is 4. And then I have one last move here is I got to convert this back to a mixed number, which if I look at it, it looks like I can get 11 holes because 4 times 11 is 44. And 44 pieces out of 45 means I have 1 piece left over out of 4. And again, if this does not make sense, please go watch the videos to remember how to do this. So that means my area is equal to 11 1/4 inches squared. Remember with area, we put the little 2 there. And we're doing that because we're actually multiplying inches times inches. And inches times inches equals inches squared. Because we actually don't know, right? If we're just multiplying those 2 units together, it'd be the same thing if I said, oh, well, what's A times A? Oh, well, that's A squared because I'm multiplying them together. It's the same thing. Or someone's like, oh, well, what's W times W? Oh, well, that's W squared. This is some cool middle school math that you'll start to really get into where you'll realize, oh, I don't need numbers to multiply. Yeah, I don't really have an exact numerical number, but I do have an answer. My answer is A squared. And in this case, it's inches squared. And that's why we put that. So just remember the area to always put the unit of measurement and then square it. Okay, cool. Let's do one more and then we'll kind of wrap this up because again, I kind of feel like we've done area, we've done perimeter, we're just putting them together to review. So here's our last one for the day. Let's go here. This time, of course, you know me, I'll use some decimals. So let's say that this is 8 2/10 feet, I suppose. And this one is going to be 3 5 or 3.5, 3 5/10. Okay. So again, what is our area? What is our perimeter? If I want to find perimeter, the first thing I'm going to do is label out everything. So making sure that the opposite sides are equal in measure, which they are. That is just how the geometry of it works. And then we're going to go ahead and add then all of our outside pieces. Now, this is one thing that we need to remember about the addition of decimals is line up your decimals. No joke, I am seeing in your work in class, there are so many of us forgetting to just put our decimals together. So if this is 8 2/10 right here, I'm going to take this decimal and I'm going to put it right underneath it, right? We're going to line up those decimals so they're right on top of each other. And then that means I have a 5 in the tenths place and a 3 in the ones place. Now I'm going to do the same thing here. Put the decimal there, 2 and 8. And the same thing here. Take this decimal, line it up right here, 5 and 3. And now we can add these things together. So I'm going to start in my tenths. And I have 5 plus 2 is 7, plus 2 more is 9, plus 5 more is 14, which means I have a 4 in the tens place and 1 whole being carried over into the ones place. Now I'm going to add my ones, which is 8 plus 1 is 9, 9 plus 3 is 12, 12 plus 8 is 20, 20 plus 3 is 23. And then my decimal comes straight down and I get 23 4/10 feet as my perimeter. So perimeter equals 23 4/10 feet. Okay. Now we got to find that area. So area again is going to mean that I'm going to multiply my columns times my rows. Right? I'm just multiplying 2 numbers. I don't need to multiply all 4 together. That wouldn't make sense because again, if we were to model this, we would see that I have 3.5 rows and it's the same thing over here. It's the same thing. So it's not an extra number, it's just another measurement. So I'm going to go ahead and take 8 and 2/10. And we're going to multiply that by 3 and 5/10. Again, the trick with multiplying decimals, here's another one. This is why we picked this, and I'm glad we can practice this. First thing you want to do, I would just estimate, right? The closest whole number to this is 8. And the closest whole number to this is 4. So if I just did that, I know my answer should be about 32. Okay, next, go ahead and ignore your decimal and just multiply this as 82 times 35. And I'm going to use the area model of multiplication to solve that because that's one of my favorite techniques. And so the first thing I'm going to do is expand this out. This is an 80. That's a 2. Again, this technique doesn't make sense to you. Go ahead and watch the video on how to do so. Now, I'm going to make these my columns. So I'm going to make an area model or an array, and I'm going to split it into 2 parts because I have 80 and I have 2. So I have a column of 80 and a column of 2. And I could, instead of drawing 80 lines to cut it up, right? This is why I just label it with the number 80. I know there's 80 there. I don't need to draw them. In fact, it would be harder if I did all the drawing. Okay, and then here's my rows. So I have 2 rows, and one of the rows is 30. And one of the rows is 5. And then I just multiply these together. So 8 times 3 is 24. And then I have 2 zeros. So that's 2,400. 3 times 2 is 6. And then I have 1 0. So that's 60. 5 times 8 is 40. And then 1 0. So that's 400. And then 5 times 2 is 10. I'm going to add these together. I'm going to erase our decimal work over here. So I have some space. Okay, so to get my final answer, I'm going to add these products together. So 4,200. And it's actually not really 4,200. We'll talk about that because it's decimal place values we still need to think about. That's okay. So 0, 7, 8, and 2. Okay, so if we go back to our estimation, we know our answer should be about, I'm going to put right here, area equals 32. So if I think about, well, okay, I ignored my decimals. So now I need to put them back into my answer where it would be close to 32. Well, if I put a decimal here, that's less than 1, right? I don't have anything in the ones place. So that's not close to 32. That doesn't make sense. If I put my decimal here, I have 2 and 87 hundredths. Thousand, excuse me. So that's 2. That's nowhere close to 32 either. That's too small. Okay, so if I put my decimal here, I'd have 28 and 70 hundredths or 7/10. 28 is pretty close to 32. That kind of like the thought of that. I'm gonna write that right now, but I'm gonna continue to double check. And that makes sense because it's 28 holes and our estimation was 32 holes. So that's pretty close, but I'm going to go and just double check again. You never know. Let's see if I put this here. Oh, that's 287. Yeah, that's too big, right? 287 is not close to 32, right? If I owed you $287 and I just gave you $32, you would be like, oh, that's close enough. Cool, right? So that's too big. So this is our answer, 28 and 7/10 or 70 hundredths. Again, its area. So I'm going to say feet squared. Okay. So that's really the work that we're doing. So really be thinking about this and how it works. Area. We are going to multiply, and it is the inside. Perimeter. We are going to use addition, and it is the outside measurement. I think those are the quick ways to think about them. That being said, as always, we appreciate your time. Keep up the good work and always continue to ask questions until things make sense. Until next time.